So, my name is Vishnu Murthy, and I'm currently a junior at Thomas Jefferson. I was first exposed to computer science in elementary school, and it's amazing to see how I've progressed from using the drag and drop NXT block programming to programming elaborate algorithms, both in school and in summer research. While learning and coding artificial intelligence is essential, I believe that giving back to the community is also as important and a rewarding experience. During my time at TJ, I've had the opportunity to serve my community through the STEM Ambassadors Program, a service program hosted by TJ, where high school students from Northern Virginia volunteer at various elementary and middle school STEM programs. Through STEM Ambassadors, I've had the opportunity to spark STEM interest in underprivileged students in underserved communities and teach concepts in computer science and robotics. Working with these students has been an incredibly rewarding experience, and I hope that many of you also pursue serving those who are less fortunate and use your knowledge in artificial intelligence and computer science to do social good. Our next presenter, Mr. Eric Schelz, uses his knowledge in artificial intelligence to help serve the global community. He's working as a data scientist and professor at New York University. He specializes in using big data to combat human trafficking, and he has worked for the Manhattan District Attorney's Human Trafficking Response Unit, serving as the senior analyst, and has even worked for the White House under the Obama administration in the past. He's deeply passionate about using data science and automation to solve social issues such as human trafficking. Please welcome Mr. Eric Schelz.
Hi, everybody. So my presentation is going to be a little weird. I'm going to give a little quick introduction about myself, and then I'm going to walk to the back of the room, and we're going to do technical demos because I'm a giant nerd, and it sounds like you all are too, so it'll be super fun. Yeah, just a little bit about me. So I work for a company now called Lucid, and we work to help law enforcement kind of use machine learning to make citizens' lives better. And the rest of the introduction actually was like pretty much everything I was gonna say. So at this point, I'll walk to the back. Oh, actually, no. I'll give a quick personal story just to break the ice, and then I'll walk to the back. So since other people have been sharing their high school experience, I thought I would do the same. So I was a C- student, just to take some of the pressure off, and I got an 1100 on the SATs back when it was at a 1600. I don't know what it's out of now. 1600? Okay, they moved it back. That's cool. Oh, wow. I'm that old. So what you do in high school, just to echo other presentations and themes, what you do in high school does matter, but maybe doesn't. Since then, I've gone on to have a really great career, as the introducer said. So, you can do a lot of stuff. All right, I'm going to go back to the back so I can give my presentation and show you all the technical stuff. I hope you all are ready to learn some awesome, crazy coding things. Test. Whoa. Hi. All right, we're back. Cool. Can you all see my slides maybe a little bit? All right. So I gave the introduction. All right. So this is my background, blah, blah, blah. All right. So the first thing I'm going to do is talk about a personal story. This may hit home for some of you. Back when I was 12, I was on a family vacation with my parents in India because I was born and raised Hindu, which is like a weird thing about me. We were in Puttaparthi, and I saw an actual slave, a man who had a metal collar around his neck, and he had to beg for food, and he was definitely owned by another person. And as a 12-year-old, since you're all kind of young, maybe you can empathize a little bit with this. The actual visceral act of seeing slavery firsthand kind of broke me inside. And I've tried to find a picture that was pretty close. This guy actually looks a lot like the person that I saw, except it was far more horrific, actually, this person I saw in person. And so that kind of just stuck with me, and I became obsessed with it. I'm still actually kind of haunted by the image of this person in the back of my head. But anyway, so that's that. So the general lesson here, and there'll be like sort of a lesson on each slide, is that if you have something that you're passionate about, something that you care about, something that you think is important, it doesn't matter sort of where you're starting off. Like I said before, I was not a good student. It's just about finding that thing that you're passionate about and then just putting everything you have into it. And so for me, whatever that thing is for you, find it and let it drive you, and it'll take you wherever you want in your career. Okay. So the next thing that I had to do, so I went to school, as we do, right? I was originally actually a poetry major, which is kind of fun that the Amazon lady said that as well. So it's like, I feel like there's a lot of parallels between all the speakers. And I was going to become a journalist, and try to figure that out. It didn't really work. And so I ended up becoming this academic and working in the econ, CS, and math departments for various people, and, sort of toiling away on papers, and that wasn't really that effective. And then after about a year of doing this, I started giving conference talks on like the prototypes that I was building, and at the push and of many of my friends who were working as developers, I was able to eventually find nonprofits and local government to work with, and then I moved on to the Manhattan DA's office, where I was able to actually make a difference. And in that role, I was able to pull people out of slavery, in literal terms. So finding your people is the most important thing if you actually want to do social justice work. I can't stress that enough. So, since you're all fairly young and most of you are like serious badasses, if you put your mind to a problem, I'm pretty sure that you could solve it. Maybe not completely, but you could at least make an impact. Probably far more than I have. Okay, so the first thing I'm going to show you is a technical demo. Can someone hold the mic while I type? All right, cool. We got a volunteer. All right, hope you can all still hear me. Yeah, let me pull a little closer. All right, I'm good. All right, cool. So let me do this guy. All right, so the first thing we're going to do is just kind of walk through a little bit of source code, and then we're going to do some command line things, which will be interesting, fun, maybe a little scary, but that's how life works. So all this stuff is on GitHub. Everything I do for the most part is open source. Okay, so we're just going to look at a few things. So the key idea for this repo, can most people see the code? Is the question, I guess. Hopefully some of you can. So basically, the idea here is I scraped Craigslist. I used two libraries, LXML and requests. If you don't know them, they're great libraries, and they help you parse HTML effectively. So I used these two libraries to basically pull data down from Craigslist. And then I went through and hand classified them, and then I applied a text classifier. This is the right way to do text classification. For all you who have done text classification in the past, this is the right pipeline to use. Naive-based classifiers are super cool, and they're really easy to understand, but support vector machines are just better. Fact. So they're faster, they're more proficient, and using this limitizer is just, it makes your life a lot easier because it will take the lemma of each word. So like if you have a conjugation like looked or whatever for the word look, you get the word look back. It just gives you the semantic root, which is really nice. So you don't have to write a super sophisticated parser. The internet has done it for you, which is true of most machine learning. And then I set up this nice little pipeline, whatever, and then I'm using an SGD classifier, which actually takes the support vector machine and then a bunch of other classifiers actually and grid searches across them, which is absolutely fantastic. And that's kind of what I'm doing, but it boils down to essentially a support vector machine with a little bit of extra magic. So that's how text classification works. I'll be around for a little bit after, I guess, if people have specific questions within that. But now I want to show you how to write your own scrapers. So I'm going to make this as big as possible. And we're just going to do something really simple. So I'm jumping into Python. And then, all right, hopefully y'all can see that. And then I'm going to import requests. And then I'm going to import lxml.html. All right, and we're just going to go to google.com, and I'm going to do like the most trivial example possible. So we're just going to get, whoops, helps if I spell correctly. We're just going to get, so we're going to get a response. All right, and now that we've got a response, we're going to create an LXML object, lxml.html, and we go from string, so we get the response, and then we get the text of the response. All right, we're going to save this in an object we call HTML, and now we're going to pull down iClaim all of the links on that page. Great, we did it. So if we want to get just the semantic URLs, we can do this thing called href. Cool, here are the actual links. That's how you write a crawler. So you just did that. I just did that in like what, 5 lines? 1, 2, 3, 4, 5, 6. Yeah, like 6 lines. That's all you need. Python is super flexible. It's high level. It's kind of magic. There's a little bit of messiness here that we could clean up with strings. We're not going to do that. I just wanted to give you a light technical introduction to this. So the way XPath works is it parses the HTML structure as like a set of, like essentially as a directed graph or a tree. And then / will look for any tag. So like A is link, any tag at any level that you, within the document. And then if you want like a sub attribute and you specifically want that sub attribute, you just do /A, and then that pulls out at that level anything that's at that level. So, you know, efficient, high level, semantic traversal of really anything you want. I mean, the HTML thing has sort of been set for this, but you could probably point these parsers, if you rewrote them, at whatever tree or graph structure you might like, and then you have a high level, flexible, regex-like language to deal with that. So that's pretty neat. So that's just the first thing that we're going to look at. So I'll take the mic back for now. So that was the first thing. Oh, actually, there is one more thing here. So that work got published. I'm going to ask you to take the mic back, sorry. That work got published in an article in Huffington Post. If you look up my name in Huffington Post, I should have had a link ready. I apologize for that. Whoops, we want the second one. So this was the results of that scraper. So I was able to discern a pattern that no one had actually found before, that on November 26th, that's like the weekend after Thanksgiving, a lot of human trafficking happens, both on the demand and the supply side. And that was kind of fascinating. It's actually what got me my job at the DA's office. So, you know, after doing this research, the Craigslist parser that I built is basically useless. It turns out that the DA's office actually has a pipeline of human trafficking cases that it gets all the time. So the Craigslist parser was like, aw, that's super cute. You made a thing. You made a thing and it used classification. That's adorable. But that's useless to us. We really need help with this other thing. So I basically spent a year just getting feedback and refining the ideas and figuring out what the people within the DA's office that were non-technical, really smart people, but non-technical folks, really needed to be able to do their jobs better. So I did some feedback, you know, did the iterative cycle, and then I ended up with the following thing that I'm going to show you right now. All right, I need you to take the mic back. Thank you. So now we enter Investigator. This is a slightly less useless tool that I invented as well. So what this shows us, there's going to be a bunch of stuff here, but oh, come on, Internet. Don't fail me now. All right, we'll wait on that for a second. In the meantime, I'm going to boot up the other server. Let me pop into that. The reason why it's being slow is not because I'm a bad coder. It's because it's on Heroku, and I'm using the free tier. And the free tier like shuts down if you don't hit it every like 2 minutes or whatever, which is really dumb. But whatever. I get it's their cost-saving mechanism. All right, so, okay, cool, that works. So we have the server ready for whenever. Each of these dots, each of these locations is a place that human trafficking is actually happening. So using Investigator, I wrote a whole bunch of really sophisticated parsers that do lead generation and actually plot on a map. So this is New York City. This is about a year old, but yeah, this is actual places where human trafficking is happening, where people are being sort of subjected to horrible stuff. I won't go into the specifics because of the average age of the audience, but it's not pretty. Anyway, so yeah, you can do a whole bunch of stuff. And this lead generation, I thought it would be super useful. People at DA's office, again, were like, oh, that's cute. That's a little helpful. It helped them organize stings and other things like that, but it wasn't really that great. Now I'm going to go over to the local version of this. And then, all right, so what actually would be populated by this search engine is not what you're going to see. I'm going to show you some fun stuff, but you're going to get different pictures back. So I essentially wrote an image search toy. Now, let's say that you were looking for trafficking. You might be able to identify someone by like a feature that they have. Like, let's say you want to find someone with red hair or something. Like, that this person who's been trafficked has red hair. You can look it up. Now, I've populated this for you all with pictures of cats because I want to just sort of show the idea that you can write an image search classifier and it'll pick out pictures of whatever you want. So this is specifically got the label tiger cat or whatever. Now the live data for the real tool obviously does not show you pictures of cats. It shows you pictures of like trafficking victims, which is really sad. But anyway, so now I'm going to jump into how that happens. We're going to look at the source code a little bit. All right, so let's go over to image saving. And this is going to be like literally all of it. We're not going to really look at all of the things. We're just going to look at a few of the lines. It's actually these lines right here that we're going to look at. So let me make that super big. So this is leveraging something called VGG16. I'll take the mic back. The VGG16 is a neural network architecture that's essentially like deep learning. It uses 16 layers. There's also VGG64, I'm pretty sure, that uses 64 layers of convolutions. I won't go through the details of what a convolutional neural network is, but you can look it up. The sort of backflip of this is that it gets 99% accuracy. That's precision, not recall. So if you give it pictures of cats and you know that one of your labels that it'll look for is a cat, you are guaranteed if there is a cat in your data set that it'll find it. You're not guaranteed that it'll find all the cats, but you'll find at least some of the cats, which is pretty cool. And to make it work, you literally need 43 to 51. You need like 8 lines of code. That's kind of nuts. So you can steal this and use it for whatever classification problem you want. I'm making use of ImageNet here instead of the pre-trained model that I'm using for demo purposes. But yeah, so that's VGG16. Pretty crazy. That's like where we're at. All right. So that was like a little bit useful, but really no one cared yet about the things that I built. And now we're going to get to the thing that is actually useful, document search. Right? So this will be the last demo. I'm telling that more for my friend here, not for any of you. So the last demo we're going to look at is document search. So let's go back to localhost. This is the best tool that I've ever built. This tiny little thing, what it does is, it lets you, so I'm going to upload just the PDF version of this talk. You can upload it, and then we can search for it based on just the title, and it'll give us back the text. This really terrible, horribly designed, not useful thing is the most useful tool that I've made. You know why? Because it solves a real problem. Search is actually like kind of hard for local DA's offices because they can't use the internet. They have to search usually tens of thousands, if not tens of millions of documents that are on their local area networks that are hard to get access to. And the DA's office didn't have a good solution for this. So I just leveraged Elasticsearch and wrote one. And that's really all it took to actually make the biggest impact. This tool, more than any other ones that I've made, has saved lives, have pulled people out of slavery and made a difference. So I think that's kind of crazy. All right, last little bit. So I've personally been able to pull people out of slavery, which has been super fun and really rewarding and emotionally powerful. My friends have done a lot of heavy lifting, and I've been lucky enough to be an early mover in this space and help people grow and succeed. And if you want to get involved, all of these lists are pretty cool. I'll just touch on the first one. So since you're all badasses, this set of people is funding you if you want to start an idea or try it. I think they're giving away $15,000 for you to work on an idea. That's probably a lot of money for a kid, right? Like, you can just, this is enough to fund your AWS thing for like a while. You don't have, you live with your parents, you don't have any like costs. So I don't know, just saying you might try for this, and I'm sure you would get it because I'm sure they would love the story. And then it could be an opportunity for you to try a whole bunch of stuff. All right, I think that's my last slide. Oh yeah, and then if you want to contact me, here's all my contact things. All right, I'll pause now for questions and let me run to the front. All right. Questions? Yeah. All right. Are there runners going around, or what's the deal? Here you go. All right. Just a second. They'll be with you shortly. Do 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 do.
He's right there.
Hi, my name is Whitman. I'm a freshman at TJ. So I was just wondering, how do you keep the data on those sites updated? Do you have to like manually update it, or just like automatically do it?
I have automated scrapers that run all the time. They run with a celery process. That's not open source, but they run with a celery process that kicks off jobs, and then we'll execute the scrapers. I also have a while true loop that runs on like the open source version, which is super shitty and you shouldn't use it. Sorry to curse. Super bad and you shouldn't use it. But yeah, you can implement your own celery queue, or if you want, you've got my contact information somehow, and you can, I can show you how to set up your own celery thing if you want to run it that way. But yeah, the open source version just uses a while true.
Thank you.
Cool.
Hey guys, quickly, I would want to remind everyone to please be quiet while these speakers presenting. It's extremely disrespectful. Thank you. On to our next question.
So like the last presenter talked about their thoughts on super intelligence and general intelligence. Like, could you share your thoughts on those two topics?
Yeah, so super good question. I think general AI is coming, and it's coming fast. We get closer every year. I don't know how much you know about like sort of the current generation stuff, but have you heard of like ladder networks or like GANs, like generative adversarial? All right, cool. So I'd say ladder and highway networks and GANs are pretty much like, we're getting close. I think we might have general AI in about 10 to 15 years. Whether it's going to lead to a singularity, I think we're actually a lot further away from that than he said. I think that we're more likely to see a singularity type event in 100 years. Because the thing is, it needs a power source to be able to keep going. I think it would run out of energy before it would be able to do any real damage. Because like general AI is extremely computationally expensive, and being able to run all that, you need a supercluster. Like, it would need to be really good at cybersecurity and really good at artificial intelligence if it wanted to become a singularity. The realistic potential, though, of a general AI existing is totally there within 10 years, for sure. Yeah, but there are other factors that limit its ability to be truly a singularity and sort of consume the human race. So we don't have to worry about that as much yet. Other questions?
So my name is Eve, and my
Okay.
question is, what other goals have you had besides stopping slavery?
That's it. That's all I care about. I'm not kidding. That's all I got. The company I work for, we focus on local law enforcement. I've pretty much spent my entire career, basically every day since I was 12, just focused on this one thing. I'm sorry that that's like really two-dimensional. I'm not really a person. I'm basically a caricature of a human being. I only care about this one thing. Yeah.
My name is Nana Sharma, and I'm in 8th grade. And how has AI helped you conquer slavery and other problems you have faced?
So if it wasn't clear from my talk, the fancy new tools are minimally helpful, but really just bringing sane current technologies into the anti-trafficking fight has been the most game-changing. I think artificial intelligence and machine learning have a lot of potential, but we haven't really figured out how to use them effectively, at least not to the point where someone can reason about it and then make a legal call about whether or not someone is slaved or not. But a lot of the automation in machine learning is super useful. I think, I'm a machine learning guy, right? Like, I really love artificial intelligence, and I try to bring it to my work whenever I can, and it's what gets me up out of bed every day. But I think that it honestly still needs a lot of work before it's going to be completely functional. Like, for highfalutin things like the stock market or curing cancer, we have a good sense of how to do this, but I think we're still figuring it out for law enforcement. But maybe in the next 5 years we'll know. Good question. Thanks.
Okay, we'll take one last question.
Better be a good one. No pressure. I'm just kidding. It doesn't have to be good.
Okay, yeah, it's probably not. Hi, I'm Thomas. I'm 9th grade at TJ, and I wanted to ask what your plans were for the future.
Yeah, just pretty much doing what I'm doing. I am an equity holder in the company I'm at, and we plan on doing anti-trafficking work probably. I have a number of collaborations through my past experiences with the various DA's offices I've worked for, as well as my connection to federal government. That's why I'm wearing this hoodie. It's not to be like, oh, I'm a nerd. This is the White House hoodie, so I figured I was coming to DC, I'd wear my White House hoodie as like a fun change of pace. But yeah, that or just make a lot of money in the stock market, I guess, like if I had to choose. But I don't know, artificial intelligence for stock market things are a lot easier than actually fixing social problems. So actually that's a good theme. I'll leave you on that since it's the last question. Artificial intelligence is super useful when there's a lot of money involved because people basically have a stake in it. That's like the thing that I don't think anyone else has really touched on here. So level setting a little bit. Artificial intelligence is super cool. It's really fun to work on. It's exciting. It's dynamic. It's great. But you need people to really be your stakeholders, which I think is why one of the previous speakers talked about like practicing those soft skills. As your soft skills improve, you'll become a better salesman, and you honestly have to kind of sell AI. It's super fun. It's super exciting. Academia is really into it, but like the professional community kind of hasn't yet fully accepted that it's like a thing. And so I think that as we continue to grow out this field, you kind of have to sell the solution, at least for social justice folks, because they're skeptical, to be honest. The reason why search made sense is because Google's been around for 20 years, so it was easy to sell that. I wrote an algorithm while I was at the DA's office that figured out whether or not whether a case was trafficking or not with 93% accuracy, and they just didn't care. I was like, cool, I took away like 90% of this person's work, so now they can focus on the other parts and actually like pull people out, and they just didn't care because they're like, I can't understand what you did. So if they don't understand it, they can't use it. And I think that's like going to be a big message, not to break any hearts, but if you want to do social justice work and outside of specifically the cancer research space where you have doctors that you're dealing with, so they're like crazy scientific already, you have to be able to make the case and do it in an intuitive way. And I'm still figuring out personally how to be a good salesman. I mean, I'm good at the math and stuff, but like sales is really hard, especially when it's complicated, right? Like that's like several PhD theses in itself just to figure out how to make it relatable to normal people. So I'd say classification is like a good example of something we figured out how to be relatable, but like general AI, reinforcement learning, prediction, regression, any of these things, we haven't really figured it out yet. Most of the visualizations we make are kind of useless. That's why the New York Times and 538 are kind of crazy, those blogs that show these really stylized visualizations. But how do you automate those visualizations? They're so directed and specific. So I don't know. I don't know what the good answer is for any of that completely. I mean, I think just keep selling hard on the things that you believe are important, and eventually it does work out. Not to be super dour, sometimes I've gotten to use artificial intelligence to be effective. So like the image classification thing, that totally works, right? Like they actually get it and will use it. They won't use the statistical classification thing that I did though, because it's too highfalutin and too weird. I mean, I just like applied my Craigslist parser, like if you really want to know what I did, I applied my Craigslist parser, put in some extra features, did some dimensionality reduction, and that popped out 94% or 93%-ish. Accuracy. So, things that produce numbers are really hard for a lot of folks, especially lawyers. But I'd say everyone gets image stuff. So I don't know. Take it for what you will. Okay, I'm done. That's as much of a question answer let me give you. Oh yeah, I get a bag. All right. Yeah, we're doing the thing. Okay, we gotta go over here.